Okay, hello. I will start this talk with some disclaimer that this presentation is intended for graphic developers interested in Science coding on modern platforms. So you have kind of a niche, but I will try to make it interesting to anybody with a technical background. So there's some introduction at the beginning. And so just about me, I joined the demo scene in 2009, where I founded Ctrl-Alt-Test with Xavier here. We've been doing a couple of 64 kilobyte intros, so you can see from Felix Workshop and Immersion in 2017. I am also a software engineer at Google in Munich, and I have a background in developer tools. So I've been working on the F# language, and then later on Bazel and the Starlac language and IDEs. So shaders. All the modern graphics rely on shaders, basically. And in the demo scene, we use mainly GLSL and HLSL shaders. And so the source code looks like this. So pretty much like a C code without the pointers, but with a couple of other built-ins. But the language looks like C. And the thing with source code shaders is that typically in a demo, you embed the source code inside the demo, and at the beginning of the demo, you send it to the GPU, where the source code will be compiled and executed on the GPU. So this means that you have to be careful with the size of your shader. And this kind of shaders have been very popular in the demo scene since 2008 and 2009. There have been this executable graphic image by IQ of RGBA, and elevated that I guess you know about. And so since then, most of the 4 kilobyte intros on Windows have been using shaders intensively. And so since in 4 kilobyte intros, so you typically have like half of the 4 kilobytes are used just for shaders, or it can be more. It can be even much more if you also make the music on the GPU with a shader, which is something that some people do. Although many people will use it on the CPU. And so it's quite important to minify the shaders. So it's a bit like in JavaScript, where you have minifiers to remove all the spaces, comments, and other things. So when you have only 4 kilobytes, you have to be very careful on how you spend these bytes. And so this talk is about how we can minify the shaders and try to put more effects in the intros. I saw this message on Poet in 2009 from IQ, where he said that they are using shaders a lot. They have been applying some tricks manually, and it would be nice if we had some kind of demo tool to do it automatically. And so I saw this message, and I thought, well, that seems like a fun side project for me. It feels related to my interest with developer tools, so I thought it was a good fit. I saw this message a few months later, so in 2010. And when I saw it, I looked around to see if there were other tools existing. And what I found at that time was that people were using some very simple scripts. So typically, use a regexp to remove the spaces and the comments. There were some Python scripts that were just reading the file line by line, just applying some regexp. And the thing is that with regexp, you cannot really parse a real language. Like it's kind of famous with HTML. Like people ask all the time if they can parse HTML with regexp, and the answer is no, you shouldn't. You can for a few things, but typically you cannot. And so I thought that, well, what we actually need is to use a proper parser, like a real GLSL or HLSL parser. And so I started it. And my first plan was to create a shader minifier in 3 easy steps. The first one is just to write a parser. And then after the parser, you get a syntax tree. you might do a few transformations on the syntax tree, and then you print the result back. So that's kind of simple, something you can do in a couple of weeks. And I started using F# because that was the language I liked the most at the time. I think it's pretty well suited for this kind of compiler-related tasks. And yeah, so a minifier feels a bit like a code formatter, because you have the input source code, and you transform it, and the output is another equivalent source code. It can seem simpler than a code formatter, because in a code formatter, the two most difficult things are where do you split the lines? Because if you want to make it nice and fit in 80 columns, then you have to split the lines, and it can be tricky. And the other question is, where do you put the comments? Because you can typically put comments in your source code almost anywhere, and that's kind of annoying. Like just to put it in the syntax tree and then print it back, they're all kind of corner cases that are just annoying. So writing a minifier is quite simple, or at least writing a simple minifier is simple. So the first step was just write the parser and the printer, and with just these two steps, you get lots of features. So first, all the spaces and new lines are just removed implicitly, because we don't want them in the syntax tree. Then the comments are also removed. The parentheses are also removed when they're not needed, because the printer needs to know the priority of all the operations. So we can just use the minimum amount of parentheses needed, and the same for the curly braces. If you have only one instruction, you don't need them. And one thing I noticed quickly is that the macros are kind of annoying. So typically in a compiler, we don't have macros because we have the preprocessing step, which kind of expands all the macros and removes all this. And then you have the language parser, which doesn't even see the macros. And with macros, you have lots of weird things. With just a hash define, you can put anything in there, and then the rest of the code might not be like parsable according to the language grammar. But the thing is that we cannot really remove the macros when we modify the code, because they might be needed, and they might have been there for good reason, so we would like to preserve them. So I updated the parser, and the idea was that, well, I would allow the macros and the hash defines in just a few places, so typically between statements or at the top level before a function definition, and just hope that no one will try to write float f equals and then hash define or hash if def in the middle of the expression, because that would just complicate all the logic and the syntax tree. The good thing is that I don't think anyone asked for this. But there are still lots of corner cases that are very annoying with macros, and most of the time we just allow macros between statements and hope that they don't mess up with the rest of the grammar and the parser. And so the first feature I did after this was renaming, because that's the #1 feature people want, is that they just want the minifier to rename their variable names to just one letter. And so the first idea was just, let's name the first variable within the file A, and then B, C, D, and so on. And since we just use one character per name, we kind of get that this should be optimal. You cannot have less than one character. So at the same time, I also noticed that it's actually valid in HLSL to write statement like this, where you have int variable equals something where you refund the variable, except that the second x in this example is not the same as the first one. So just imagine you have a global variable x, and then locally you might define a new x that will define a new value based on that one. So that's just the kind of corner cases where you need to think and take care of when you want to rename things and do other transformations. And the second feature is that when I looked at the minified code, you typically get something like this, and you notice that there are lots of long words. Here I highlighted all the float words, and you can see there are lots of floats. You can also have lots of smooth step and so on. And you can see that, well, it seems to take a lot of space. And the classic idea when you try to minify things and do like code call thing, you might have seen in C, is that, well, maybe we can just do this hash define f float, and then we just use one character for all of these floats. So this can reduce the size of the shader significantly. And so just after this, I started sharing my tool with other people. I've tried it on a few shaders. And of course, when I tried it, I found some bugs and I iterated and so on. And I noticed some massive savings, like hundreds of bytes. And then, when I was talking to people making those 4 kilobyte intros, the question after that was that, well, it's really nice, but how much do you save after the compression? Because a 4 kilobyte intro is compressed, obviously, and the shader is part of the binary, so the shader is also compressed. So you are not going to save like 100 bytes after the compression. And so the question is, well, how do you estimate the size of the compressed file? And you might think that, well, it can be easy to estimate the gains. Like if we save 100 bytes and the compression tool has like compression ratio of like 65%, let's say, you can compute that we will save 35 bytes. That's a simple computation that you can do, but it's just wrong. When you try it, you are not going to save 35 bytes. It can depend on lots of things, but when I tried on some examples, well, that just didn't work. One of the reasons is that it's kind of too optimistic, and that when the size of the shader gets reduced, we don't get the same compression ratio. Like if we remove some of the overhead, the rest will compress a bit, maybe not as well. So I thought, well, what if we just divide that number by 2 or by 3, and that's like 10 bytes that would be saved? And that's also another estimation that's just wrong. It's not working like this, kind of more complicated and sometimes frustrating. And the thing is that, well, if I just reduced the size of the input shader, like I made it smaller, and I compress that file, surely that should reduce the output size as well. And, well, the thing is that, well, no, it just depends on a lot of things. And, like in many cases, sometimes you just reduce the input size, you compress it, and the result is bigger. And that's something that's, really frustrating, because you spent a lot of time on your optimization, and you just have to throw it away. And after that, there have been lots of examples. Like, so recently I've been working on an 8 kilobyte intro, so the shader is much bigger than in 4 kilobyte intros. And there were lots of smooth steps functions. And some of my friends said, well, are you sure you don't want to have like 1 byte for the smooth step and just hash define as smooth step? Like, it will really save a lot because there's so many smooth steps everywhere. It has to work. And I tried it. It saved like 700 bytes before compression, so that's quite a lot. But when I compress it, it just gets bigger than it was before. That's the kind of trick that you might want to try, and then you have to revert it. In many cases, it doesn't work. And the reason is that when you have lots of smooth steps in your code, the compression tool will notice that it's kind of redundant, and it will take care of this. It will say, oh, I know smooth step. It appears a lot of times. I will put it like really small. And so if you define it yourself in your code with a hash define, you are kind of doing the same work as a compression tool. And it's kind of, you are just stepping over each other, and it's not a good idea. At the same time, I said before that we could rename all the variables with ABC and so on, but also, it's not always optimal. I have seen some shaders using like sometimes 2 letters per character, and then I rename this with just 1 character. It was sometimes a bit bigger. So again, it seems to be complicated to guess the estimated size. So again, that was a bit frustrating, and at some point, well, I have no idea what I should do. Like, it seemed to be just magic or random, because I guess the compression tools work so well that it's difficult to outsmart it. So yeah, you can easily estimate the final size, but your estimation will be bad, so I guess don't do it. And so after that, we decided to use a new strategy. First, for all the transformations that we apply in the Shader Minifier, we want to either reduce the amount of information, like remove things that are not needed, because typically if you just remove, that should be smaller, or try to have some kind of repetition in the output code, because this repetition will compress well. But most importantly, that we should really measure things and don't guess. Like, don't implement an optimization if you are not checking it afterwards. Most of the time it's very difficult to guess. And so in Shader Minifier, we've tried many of the different transformations. And the idea is that we keep the things that work well on average. Which means that some of the transformations might not work well on some specific intro. That's sad, but we are just building a tool, so we do things that work well in general. And then, so we introduced a new testing process in the development of the tool. And so the idea is that each time we modify the tool, we first want to run a shader minifier on many shaders. So we've written some like unit tests, and then we also took some shaders from actual intros. And so we run the shader minifier on a bunch of files. We look at the diff. So we really wanted to know what the tool is doing, just to make sure that it's actually correct. We also run a GLSL compiler just to double check that it's still compiling. And also for the compression size, we run the shader minifier on a bunch of files. And once they are minified, we compress this output. And we compare the output of the minified shaders before and after the code transformation, so that we actually know if it's working and if we should do it. So this is just an example of the diff. Like, we implemented this transformation where you have like you assign it to variable something and then return, and then you merge both of them. So we have this kind of diff where we can just double check that the transformation is working on the shaders. And then we also compress some of the files. And so here you can see that before the change, we have the sizes, both the uncompressed size and then the compressed size. And after the change, we have again the uncompressed and the compressed size. So in this example, you can see that the total number of bytes compressed was reduced by like 20. So that was so this code transformation is working well on average, even though there might be some corner cases somewhere. Then we also looked at renaming, and one trick we found was that we should use a function of overloading. If you have two completely different functions that have different arguments, they can still have the same name. And so this saves some bytes on average, because you have the same name reduced multiple times. And so you have this f and parentheses copied over and over. And we have shadowing, where you can reuse the same name multiple times. Like if you have a global variable and then a local variable, they can have the same name if you don't need the global variable in that function. And again, that was saving some bytes. And for choosing the variable names, we tried lots of different things, so just A, B, C, D in order, and so on. Someone suggested that maybe we could try subsets of the common function names. Like if you have lots of smooth steps, maybe you could have variable S and SM and maybe SMO, and lots of other things. We also try to do renaming based on the type information. Like each time the variable v appears, it should be like a vector, and so on. But at the end, all this was not working well. And the solution was to just look at the context where the variable appears in the source code. So the idea is that we look at all the uses of one variable in the source code, and each time it appears, we look at what character is before, what character is after, and then try to optimize things to optimize the frequency of some pairs of characters. Still not optimal. It works better than what we have tried on average. One complication with renaming is that the variables can be used somewhere else. So first, the variable name might be used in the C++ application, like if you have a uniform and you want to set it. So we need to define some values to tell the C++ code how the variable will be renamed. There are also some complications when you have multiple files in the same shader files in the same application. Like if you have the in and out global variables, they should be renamed in the same way in both vertex shader and fragment shader. And then there's also the question is, well, what if you had some hash included in your input and a lot of code got duplicated between different shaders, like the same function appears in 10 different shaders? This is not well handled yet. I know it's super useful for 64 kilobyte intros. We haven't had much feedback on this yet, so it was not prioritized. But just file a feature request, and we'll just do it. Or wait for us to release our next 64 kilobyte intros, because we will need this. One nice transformation is with inlining. So if you have a variable used only once, you might say, well, it's not needed to have this variable, and we can just inline its value where it's used. This is something we try to do automatically. There are lots of corner cases because it changes the order of execution of the code, which might break the shader if there are some side effects somewhere. So we try to be careful and do it only when we detect it's actually safe, by looking at all the side effects that are happening. You can also manually annotate your variables with I underscore, just to tell Shader Minifier, I want this to be inline everywhere. Yeah, and we also have some code to inline the functions. It's still very limited. But again, it can be done automatically or with a manual annotation. Right now, it works only for the very simple functions that can be simplified to just one return statement. Yeah, so just some example of inlining. Here you have this f variable, which is equal to v minus clamp something. But this is used only on the next line, so this can be inlined. The x over here is used twice, so we don't inline it by default. Yeah, and so in the message from IQ in Poet that I showed at the beginning, it specifically mentioned one trick with the smooth step function that you can reorder the arguments of the smooth steps to always have a smooth step 0, 1, and then there's a number. So with wide it doesn't work well on average, so it's not enabled by default. I think it needs some manual work on top of it. So this might be a good trick in some cases, in some demos, if you pay attention to it and use it properly, but in general, it just doesn't make sense to apply it blindly. So yeah, just because we run the compression test on a bunch of intros, we decided, well, that shouldn't be on by default. There are things like dead code removal, which was not needed at the beginning when I worked on Shader Minifier, and I was really focusing on the 4 kilobyte intros and assuming that the code was already optimized by the user. Later, I wanted to extend the scope of the tool and make it useful for more people. And as soon as you have bigger shaders, you might have dead code. You might have like some unused functions in your code. And it's not always easy to spot these unused functions when you iterate on your shader. And same for unused variables, code after return. If you have this kind of a statement with like a Boolean and then ifs somewhere, sometimes it's useful to have this kind of code, and Shader Minifier will just take care of this. It will inline these enable reflections, and then notice, well, it's just if false, so I can just delete all of this. With vectors, there are lots of tricks. Just some examples here. That first, the vector fields are renamed to always use X, Y, Z, W instead of RGBA, for example. The idea is just to make it the code consistent and always use the same vector fields, because it's just equivalent in GLSL and HLSL. And just other cases here. If you have a vector with multiple times the same value, it can be simplified. In the call to vector, if you have a float, you can actually put the int without the dot, because I checked the GLSL specification, and it says, well, we are doing an implicit conversion here, so you can put an int and save your dot. Just removing all the dots reduces the size of the shader, but after compression, it doesn't make a big difference. We still do it, but it can help with a few bytes, not much. The last one is also interesting, that even if a call is a vex-free, you might think that this would change the code, but GLSL says that, well, we just pick, like if you have too many components in your vex-free, we just pick the first ones in order. And so even if call is, has 3 components, it will just keep the first 2. And other things implemented, like replace some if-else statements with this question mark colon ternary operator, replace the pi constant with alcos -1 instead of having all your digits. Some arithmetic simplification, which is useful in particular when things get inlined. Group adjacent declarations, and other things. Just look at the manual. And so lots of things have been updated in the last few months. So if you checked out the Shader Minifier 1 year ago, you might notice lots of new things, including the manual, which is much more complete than before. And then I wanted to look at some actual intros just to see how things are working in practice. So first, I wrote this blog article in 2010, where I just compared the size after compression with Shader Minifier compared to what people were doing with manual optimizations. And so I got some pretty nice results on many cases. some intros were actually really well minified by hand. Like if you try Shader Minifier on elevated, you are not going to save much because they already put a lot of work in it. But for many intros, it can actually save some bytes, even if it was optimized by hand. So yeah, then that was 2010, so a long time ago. So I thought that, well, maybe I could just make the same comparison again with like modern intros and see how well it works in practice. One difficulty is that when I looked at the winners of the previous revision, for example, they are all already using Shader Minifier, so I don't have much to compare with. But I found this one from 2012. So yeah, it won revision. It looked pretty nice. And I noticed that it was not using Shader Minifier. And so I looked at the diff and see what Shader Minifier could do. And so you can see a few transformations. Like at the top, just remove the dot zero. Then line 31, there's a float with a zero. Yes, exponent minus 0.07. You can just remove the zero. The 10,000 dot can be replaced with one exponent 4. And yeah, a few transformations like this. And then that's the interesting thing with inlining, that you have on line 55 this vec for L with a very long statement, but this is used only once, line 71, and it's actually safe to inline, so you can just put it there and remove the L variable. So, of course, I had to try it after compression as well, and I noticed that I could save 74 bytes on this intro. This isn't just an estimation because I just picked like a framework and put the shader, like the old shader and the new one. It might be slightly different with the actual C++ code, but I think that should be a reasonable estimation. I also found this one, final stage, so winner in 2017. So again, I applied Shader Minifier. I noticed something interesting is that they were using the curly braces everywhere. Like even if there's just one statement, like always curly braces. This can be a decent strategy because it's going to compress well. If you just do things consistently, it might not be bad. Shader Minifier is not doing this, so it just removed everything. And you can see on line 94 that you have 3 statements, and Shader Minifier will put them all in one statement, separated by commas. And yeah, it was doing a couple of transformations like this. But so what I noticed is that all these transformations actually didn't help with the compressed size. So I got the exact same size before and after. So you can see just removing bytes here in this diff, but it didn't help. Until I looked at inlining, and then when I enabled the inlining in Shader Minifier, it managed to inline one variable, and it also found that there was one unused variable, like this g equal f minus 57, is actually not used in the intro, so it can just be removed. And that's the kind of thing that it can be very difficult to spot it if you minify things by hand. But it's also always useful to have a tool that is actually looking at everything in a systematic way. Another case study, some intro that is going to be released soon. You're going to see it. The thing is that it's an 8 kilobyte intro, so you have a much bigger shader code than in 4 kilobyte intro that we saw before. And as I was working on this intro, I realized that, well, I need a really good shader minifier. Because with 8 kilobytes, you can have like a bunch of code. And it's very painful to optimize everything manually. And more importantly, I wanted to have like some readable source code that I can actually maintain and iterate on. Because I want to be able to make changes to my shader and to my intro till the last minute. So if I minify everything by hand, then usually you cannot really read the code anymore. And that's the nice thing with the tool. And just some numbers that I looked at the size of all the shaders we had, and that was like 43 kilobytes. And that's funny to think that we put 43 kilobytes into an 8 kilobyte intro. It just, well, when you remove all the indentation and comments, you get like 25 kilobytes. And then you simplify things. You get 22 kilobytes. You rename all the names. You get 17 kilobytes, and you compress with Chronicler, and you get like 5 kilobytes, something like this. And yeah, so this is some spoiler of some part of the source code. The idea is that we wanted to keep it kind of readable. And so yeah, it looks, it doesn't feel like the code is designed to be in an 8 kilobyte intro, in my opinion. It looks like something you could see on Shader Toy. And that's very, very nice. You want something easy to maintain. And so yeah, you might have noted that there have been lots of improvements to Shader Minifier in the last few months, and this was because I just wanted to bring down the size of this 8 kilobyte intro. And so with just the new updates of Shader Minifier, I was able to shave hundreds of bytes. One important thing is that with the renaming, it was not working well before when you had you wanted to rename things across multiple files. And so in the past, you had to disable this renaming for all the variables that are shared across multiple files, like all the in-out variables. And then, yeah, there have been lots of improvements. I think many of them are due to inlining, because we were able to inline lots of things. So lots of variables were removed. And when you remove one variable, that means that typically save bytes. And that just makes the code use always the same variable names everywhere. And so in general, Shader Minifier is useful either to save bytes or to save time. It just really depends on your use case. Like if you work on a tiny intro and you, yeah, so it's, yeah, so on the intro I showed you, it just saved us a lot of time, because if we hadn't this tool, we would have to do all the work manually, so it saves time. But even when you spend some time, it can still save bytes, because I showed you before, with all the hand-optimized shaders, it's sometimes useful to have a tool on top of this. Then I wanted to have a section with some tips and tricks. The section will be short, but I just saw some examples in Elevated that you have these kind of things. This code looks kind of redundant, but it compresses well. I like that they use like this O plus equals -1 everywhere, even if the O variable is not used at the end. Because like, if you had written O plus 0.1 and then O plus 0.2 and O plus 0.3, it wouldn't look as similar and as redundant. So this kind of writing can be useful as long as you measure things. Yeah, always check the compressed size. Yeah, so the suggested workflow for Shader Minifier is to use it as part of your build. And I think it's useful to submit the minified code in your repository. Because like each time you modify the input code, you are going to look at your commit and see what is the actual impact on the minified code. And you might spot some things that are not fully minified or things that should be optimized. And so one thing is that you can just edit again the input source code to make sure that it optimizes better. So for example, if you want to force inlining or something, just put I underscore or something, and it will just be inlined. You might also do some optimization that Shader Minifier is not doing. Yeah, and the interesting thing with this inlining is that yeah, sometimes, like if you have a constant, it's sometimes useful to just inline it everywhere. Even if it's used like 20 times, it's sometimes better to just inline the value everywhere instead of defining your own variable. Yeah, it will make the code more redundant at the end, but it might compress better. I also found it very useful to always include the size of the intro in your committed description so that you can see how things are evolving. And if you see any jumps, you can look at it later. Yeah, I wanted to have another slide with tricks. I will just ask you in a minute. And the tool is integrated in a few places, so you can try it online. Some people find it very convenient. It's also in some 4 kilobyte frameworks, like Leviathan, Combo Filler Studio. There's this Post-Proli tool, which is also very nice. And yeah, for the future work, so I have some ideas of things to do more in Shader Minifier. It will just depend on the feedback and on what I actually need in my own intros. Yeah, there are multiple ideas to make things compress better, like better renaming strategies. Some people ask for better preprocessor support. If you want to have like if-def in your code, to have multiple ways of writing the code and just enabling or disabling some features, or just a more readable output, because it's very common to look at the minified source code, and it would be nice if the minified source code, like if the minified source code is in C++ with this C++ strings, you can have some C++ comment next to it, which can be useful for debugging the minified shader. Yeah, and I think that's all. So if you have any questions, you can ask them. Or if you want to share your favorite size coding tips with other people, please do.
Is this on? Oh, okay. Thank you for the really nice talk. That was awesome. And thank you for writing that tool in the first place that basically everyone uses. So a couple of questions. You described a very manual process of like doing this optimization step for step for step. Did you consider to kind of do it in a feedback loop automatically? Like grab the Crinkler report, see what's good, what's bad, and maybe do something in those areas? Because that is, like, I know it's a lot of work, but theoretically you could, like, go through a couple of permutations and automate that. Crinkler is kind of doing some of that with the section reordering, where it tries a couple of permutations. So that may or may not be an option, because you have, like with Shader Minifier, you have a lot of settings you can permutate. You can change the naming strategies. You can make, like, maybe you can give the user a feature to do something about that. I don't know. Did you consider that?
Yes. Yes, that's one of the ideas. There are multiple ways that we could have this. One option is just to ask Minifier to generate a bunch of shaders, like just try lots of different options, give me like 50 different shaders that do all the same thing, and then you could use that list of shaders in your tool and make the loop yourself. So that's one option. We could also think about running the Crinkler compression library as part of Shader Minifier to kind of do it. I do not really want to have a dependency on Crinkler now, because yeah, it's not always convenient to have this kind of dependency, especially when you want to have the tool online, compile as WebAssembly on other platforms. So I guess yes, the one solution is just generate a bunch of shaders and let the people do it themselves.
Okay, I also have a question. Like you asked for some tips to share, and I noticed when you mentioned connecting uniforms with the host code that people would parse the names. That's something we don't do. Like we always set uniform locations in the shader, and then the tool like auto connects it and figures out those locations. So we never even look at any kinds of strings. So that's something that worked super well for us, just as a tiny detail.
Okay.
Thank you for a great presentation. So the idea with minifiers is like you parse the code and you get a syntax tree and you have that in some representation in memory and do transformations on it. And then you pretty print. And the output from the pretty printer, that's what you put in the intro. Yeah. Have you considered putting the pretty printer in the intro and sort of optimizing the representation to be like a syntax tree that is perhaps even smaller? Have you thought about that?
I haven't. I'm not convinced that would be beneficial in 4 kilobyte intros. Yeah, I guess that would be interesting if someone wants to try it. But yeah, that would be basically try to use another representation of the same source code and then convert it in your intro. I just feel like it would not work well with the compression step. Like, might make the things smaller, uncompressed, but then you have all this logic on top of it. So I'm not convinced it's a good idea.
Okay, so this was also one part of my question, and the other part is what is the progress about including compiled shader code in intros? Like if you write your intro using Vulkan and use BRV, the compiled bytecode, is that already a thing? Or do you still want to use the source code in the intros?
Yeah, so I think in general using the source code works better. So that I haven't tried it myself, but so from what I read from other people, using the source code is still the best option for size, at least if you're in for 8 kilobytes. No question left? Yes. Yeah.
Can Shader Minifier read its own output?
Yeah, not really well. Yes, so that's something I didn't mention. Is that so in the output of Shader Minifier, it will try to reuse the function names as much as possible. So it will use a lot of overloading for the functions. So always use the same variable name. But as the input of Shader Minifier, this is something that we do not handle well. But that's something that we can fix. Is there any need for running it? So do you have any use case where you want to run it multiple times?
I prefer to keep working on the minified code, and yeah, I think there are certain tricks you can only notice when you really look at the minified code. So I'm used to looking at minified code.
Yeah.
But it's been a while since I used Shader Minifier because I wrote my own tool. Speaking of which, one tip I haven't heard you mention is moving all uniform defines and all global variables to the top. That, in my experience, can save some lives.
Yeah, so move the local variables to
all the global variables on top and then all the functions.
Yeah, yeah, that's not something we're doing yet. Yeah, I think we have to be careful with this because, like, if things are modified in multiple places, I I get a lot of corner cases that we need to pay attention to in the tool, but yeah, that's something we can investigate. And yeah, just to come back to your first point, that I personally prefer to iterate on the non-minified code. And so if I spot something bad in the minified code, I will just modify the input first. Yeah, mainly because there are all the comments and all the names and so on. But I think your use case is valid, and this is something where we could do, like a better support this workflow of iterated on a minified version and iterate like this.
Do you or anyone know if it's legal to name variables after built-in functions like float, smooth step, equal stuff? Just asking.
I haven't checked. Yeah, I don't think it's possible. Yeah, I guess yeah, that's something to check. All right. Oh, one question. Two.
Yeah, thanks for the presentation. Just some tips I've encountered is like moving the globals to the top, and also like reordering your functions and all the kind of like code that don't depend on each other. So like trying to just switch the order of your define your functions can have like huge impact after compression.
Okay. Thank you. And I think that yes, this one would fit with suggestion before by Lars, that we could just try different orders and different naming ways, and just generate a bunch of shaders and see what compresses better.
Yeah, hi. Thanks for the tool, by the way. I have to second the thing that you wrote down about multi-file shader minifying, because it's something that I've been waiting for a long time as well. For example, for doing 8Ks already and not only 64Ks, you tend to use some sort of kind of library shaders where you don't have to light stuff here, but you want to include the snippets of the same kind of shader source with your entry point shaders. So when minifying, it has always been a problem that you can only minify one piece of source code. But if you want to have some sort of libraries, you need to kind of pass somehow the renamed tokens to the other places in the shader that also use the same functions or globals or whatever. So what are your plans for this kind of multi-file isolated renaming?
Yeah. So I think I implemented something at some point where it tried to always name the same input variable to the same output one. Like if you have like the word light in many different files, they will all be renamed in the same way. This is something that was working, except that if you have like lots of different variable names, that means that in the output you will have like a bunch of different names, and you will typically end up with like two letter by variable name. That might still be better if it can help you. Yeah, I guess we can also look at other solutions. And I think in general, for all the feature requests, I would invite you to just put it on GitHub. Yeah, because I think there are lots of things we can do, but it just depends on what users want the most. So it's very useful to prioritize the work. Yeah.
Thank you.
Yeah, one other problem with this library style include scheme that we also use is that different shaders will have different parts of unused code in the library, like no no shader will use all of the library functions. So there will just be like, we will end up with like 20 different shaders, each uses a slightly different subset, and then you compress each one. So even if you keep the tokens consistent, you would have like different snippets. So the compressor can never look at the entire library at once. But even if the snippets are identical, because the minification kind of hopefully happens to be deterministic and do the same thing every time, it will still be like different collections of snippets. And so I don't know how much that hurts the compression, but I'm sure it hurts something. So, but I also don't know how that would be solved in practice, because like Shader Minifier, does Shader Minifier know that this part should be a library? Does that need to be a feature? But then again, our system has like recursive includes, and there's not just one library, so it's like a complete mess, and that's obviously way too complicated for Shader Minifier to go to. So I also don't know what I'm even asking for. So maybe you have some ideas what would be practical.
Yeah, I don't have really good answers for this. It seems like, yeah. So one of the reasons I focused first on the 4 kilobyte int was that, well, first there are lots of people doing it, but also it's much simpler when you have everything in just one file. And then, yeah, the thing is that when people make bigger things, you tend to have a mess of things, but everyone has a different mess. So that's very difficult for a tool to provide a good solution. Maybe we should try to uniform, yeah, like find a standardized solution for this. Okay, thank you.